Welcome, class, to the Intro to Java Programming. In this lesson, we will introduce object-oriented programming, cover the four major building blocks, and provide some visual examples to help build a solid foundation. The two most common programming paradigms are procedural programming and object-oriented programming. Procedural programming is about writing sequential code procedures or methods that perform operations on data. Object-oriented programming is about creating objects that contain both data and methods. The four building blocks for object-oriented programming are encapsulation, inheritance, abstraction, and polymorphism. Let's briefly cover the definition of each term. Encapsulation simply means binding object state, known as properties, and behavior, known as methods, into a single unit and enforce modularity. If you're creating a class, you're doing encapsulation. Encapsulation also ensures that your data is hidden from external modification, also known as data hiding. Inheritance is the mechanism by which an object acquires some or all properties and methods of another object. It creates a parent-child relationship between the two classes. Abstraction means using simple things to represent complex things. Abstraction is a process where you show only relevant data and hide unnecessary details of an object from the user. Polymorphism means existing in many forms. With the use of contracts, overloading, and overwriting, we can enforce simplicity, which helps make the code more extendable and easier to maintain. It lets programmers use the same word to mean different things in different contexts. One other term that falls between abstraction and polymorphism is the interface. An interface provides a mechanism that allows unrelated classes to implement the same set of methods. It is another form of abstraction meant to have a simple thing represent a complex thing. With the use of these building blocks, programming becomes easier, faster, and more dynamic because we create components that can be reused in different ways but still maintain security. You will see the acronym DRY, don't repeat yourself, from time to time. Don't write the same code more than once, reuse the code instead. Yes, these terms are vague until you better understand the true meaning. Let's go over a visual example. Let's say this puzzle piece is a class. If you're creating a class, you're doing encapsulation. Inside the class could be constructors, properties, and methods. The properties are data fields and object state. The constructor and methods are the behavior. The contents of this class is a single unit with a single responsibility. Properties can be public or private. Constructors and methods can be public or private. Expose constructors, properties, and methods to other classes that need to know this information. Hide constructors, properties, and methods from other classes that do not need to know the inner workings. This is data hiding. Inheritance is accomplished by taking two classes and connecting them together in a parent-child relationship. These two classes can be called the superclass and the subclass. The superclass is the class being inherited from. It is often referred to as the parent class or the base class. The subclass is the class that inherits from the superclass. It is often referred to as the child class or the derived class. Both classes should follow all the rules of encapsulation. The parent class could have private constructors, properties, and methods, and the parent class could have public constructors, properties, and methods. The child class could have private constructor properties and methods, and the child class could have public constructor properties and methods. The child class can access all the public constructors, properties, and methods of the parent class. The parent class cannot access any constructor, property, or method of the child class. It is common for several classes to inherit the parent class with the purpose of utilizing existing code. Remember, one of our goals for object-oriented programming is reusability or DRY. Don't repeat yourself. Inheriting a class that has code we need is one way to reuse existing functionality. Abstraction is using simple things to represent complex things. My favorite example is the remote control for a television. The power on, power off button is simple to use. Behind the scenes, there is a complex communication process between the remote control and the television that turns the device on and off. How the remote control actually works is abstracted away or hidden. Simply clicking the button is the only thing you need to know. Abstraction can be achieved with an abstract class or with an interface. Let's go over the abstract class first. The abstract class works much like inheritance. The two classes are connected together in a parent-child relationship with the abstract class as the parent. Both classes should follow all the rules of encapsulation. The parent class could have public and private constructors, properties, and methods. The child class could have public and private constructors, properties, and methods. The child class can access all the public constructors, properties, and methods of the parent class. The abstract class cannot access any constructor, property, or method of the child class. There are a couple of noteworthy differences. The abstract class cannot be instantiated by itself. Instantiate is when you create an object of a class. Using the new keyword will create an object of a class. Another difference is the abstract class is allowed to have an abstract method, which is a signature only, no code block. The child class must implement the abstract method. Implement means a class must contain the specific method and the code block must be written. Once the class implements all the abstract methods, it is considered to be a concrete class and can be instantiated. Abstraction can also be achieved with an interface. An interface and a class can be connected together to form a parent-child-like relationship. However, the interface is a template that the class must follow. Inside the interface can be abstract methods, meaning only the method's signature is declared, no body, no code block. The class must implement all the methods defined in the interface. Many different classes can implement the same interface. Each class must implement all the methods defined in the interface, but each class will implement the methods in their own unique way. Polymorphism means existing in many forms. Specifically, classes and methods can exist in many forms. Let's review the three different types of polymorphism: dynamic, static, and object reference. Dynamic polymorphism is achieved with method overriding. In a parent-child relationship, the parent can have a public method like getMonsterName. Let's say the parent returns a string value, default monster. If an object calls the child object and requests the getMonsterName method, the value returned is default monster from the parent class. With dynamic polymorphism, the child class can also have a method, getMonsterName. Let's say the child returns a string value, goblin. The child class can override the parent's getMonsterName method. So now, if the object calls the child object and requests the getMonsterName method, the value goblin is returned from the child class. The child overrides the parent. With an abstract class that has an abstract method like getMonsterName, remember the abstract method in the abstract class contains no code block. The child must implement the abstract method. So now if an object calls the child object and requests the getMonsterName method, the value goblin is returned from the child class. The child overrides the abstract class. With an interface, there could be an abstract method called getMonsterName. The class implementing the interface must define and override the method. If an object calls the child class and requests the getMonsterName method, the value goblin is returned from the child class. As you can see with these three examples, one method call has many forms. Static polymorphism is achieved with method overloading. This can be done with abstract methods in an interface and abstract class. This can also be done inside a class. If a class has more than one method with the same name, but their arguments are different, this is method overloading. Constructors can also be overloaded. One method call has many forms. Remember, overloading is done inside a single class. Overriding is done between two classes. Object reference polymorphism is achieved with an abstract class and interface. Let's say we have a monster. It could be an abstract class or interface. This class has an abstract method called getMonsterName. There is also a goblin class that will implement the getMonsterName method. Object reference polymorphism is accomplished by referring to the goblin class by using the monster class reference. Here is a code example. Monster equals new goblin. Now, when monster.getMonsterName is called, we look for getMonsterName inside monster. This method is overridden by goblin. The value from goblin is returned. The important part to remember with object reference polymorphism, you can have many classes using a monster abstract class or interface. The variable monster could be a new goblin, a new skeleton, or a new dragon. And the request for monster.getMonsterName method will return the value from the appropriate class. one variable that has many forms. You should now have an introduction to object-oriented programming and the four major building blocks. A simple definition and example were provided for encapsulation, inheritance, abstraction, and polymorphism. The following lessons will help build a better foundation with these building blocks, including the abstract class and the interface. In the next lesson, we will discuss encapsulation. Remember, future senior developers, make it work, prove it works, then make it better. Ready? Break!